When you deploy an application, you want to know how is the weather in there. You will want to know the resource usages, RPMs, response times, custom business metrics, etc. With OpenTelemetry Metrics, you can get all of this information. First, let's start with some of the terms of the OpenTelemetry. We will talk about the meter provider, meter, instrument, and metrics. Then we will jump into the code and we will implement it in our order API. First one is meter provider. It is the entry point for all metrics. It is a global singleton object in an application. Then meter provider provides a meter. It defines a group of instruments. You can use one meter for one application. Actually, it can depend on your module or component design. Instrument is a type of the metric, like gauge, histograms, and counters. And instruments creates metrics. Metrics is the data itself, like when you have an endpoint, you get, let's say we have a counter instrument, and when an endpoint gets a call, the counter increments. And that incremented data itself is the metric itself. So how we will create an example in our application? We will actually generate some metrics in our application. We will create response times, RPMs metrics, and we will create two custom metrics that will be, we can create shipped orders and cancel orders. We have an order API, a simple API. Just we are creating an order, we are shipping it or canceling it. Just add code application. We will get that data, generate that data. We will send it to Prometheus within our with our metrics endpoint. We will see it. Then we will create visualization with that data in our Grafana application. So this is actually from our previous videos. If you didn't watch that, you don't have to watch that videos. Those videos are about actually creating endpoints in Golang application, integrating Swaggo and Golang library. And our last video was about distributed tracing with OpenTelemetry, and this video is about metrics. You don't have to watch them. It is actually the same simple order API application. So we have an order API. Let's see with our Swagger. We have a get endpoint. We have a ship endpoint. It's actually set the is shipped column to true. Boolean type, and we have an order post endpoint, and that is creating orders like that. And we have an Postgres SQL database. We have three tables: orders, order line items, and cargoes. Let's jump to the code. This is our application. We have an order API. So within our API, we have a controller like get order by ID, as you saw in the Swagger. We have a create order and we have a ship order. So first, we will actually create our CI/CD files, so we can get our Prometheus and Grafana and OpenTelemetry CI/CD files in a Docker Compose. So when we write to the code, we can export that data. So I will just copy those data So we have a Prometheus file. Prometheus, yes. This is actually an OTel, so OpenTelemetry collector. It will get that data from the Docker. Import 8889, and we need an OpenTelemetry config file. So we will get that to here. That is actually connecting to Prometheus and OpenTelemetry and Jaeger together. Jaeger is a UI for distributed tracing. We will not use it Jaeger in here, but if you want to use Jaeger for distributed tracing, you can watch the previous video. So what do we have? We need a Docker file, right? And this is our Docker file. This is a just simple Golang Docker file. Nothing out of standard. Like I said, nothing out of standard for YouTube OTel metrics. Actually, right now our application is YouTube OTel YT OTel tracing. Because of the previous application, we will rename it to the OTel metrics, like in here, YOT OTel metrics. And last but not least, we have Docker Compose application. So in here we have our Postgres, just a default one and default credentials. We have our Prometheus with 1990. We have our Grafana. We will create dashboards in there. We have our OpenTelemetry collector, and we have our Jaeger for distributed tracing UI. I will share all of this data in my repo, so you can get them. It will be in the description. So we have our CI/CD files, and let's rename our application as well. What is our module? And let's say it's metrics, IT or metrics. Okay, so let's first start our Docker compose. So Docker compose up and away. Okay, it has created Grafana, OpenTelemetry collector, Jaeger, Prometheus, etc. Nice. So let's check our database first. Refresh. Yes, these were actually created before in our previous videos, but you can just create orders with order endpoint or just in table itself. We already have the DDL files as well in our GitHub repo readme, so you can get them from there, and you can just follow and write code with me as well. So let's get to here, our main.go, and say run first. See what do we have. Okay, it is in port 3001. So we already opened it in here, right? Yes, it is on here, our Swagger. Yes, we have our Swagger. I didn't start refresh it because I had the GUID in there. Okay, that means we can start. So first thing we will do is actually initialize our metrics. So when we go to our trace file, in our main Go file we have an init tracer. So that one is actually creating a tracer provider, and creating a tracer provider like our metric provider we talked. And so we need to actually have a metric provider and init our metric for our application. So in order to create a metric provider, we don't have actually metric provider right now, so we need to actually get that. Like for example, we have a trace SDK, and we need to have the metric SDK as well. So I will get it. So create a terminal. Okay, so go get SDK metric. Yep, thank you. And I don't know we have an OTP metric HTTP as well. Oh, sorry. Okay, right now we have metric. So this is trace.provider. So we have a func init tracer, and like that we will have a func init meter. Return a metric. Yes, we have a lot of metrics, right? So actually we will have, like, I can just copy it, say metric and say metric 2. Oops, like that. Metric 2 that we can provide. Yes, first thing is we need to have our context, then we need to have our exporter. We will export our meter to our local, and it is like that. So they are the same thing, but not trace HTTP, but OTP metric HTTP, which we don't have that right now. So metric HTTP, yes, but we don't have that, so we need to import it. So I will just copy it and say go get like this. Yes, nice. It's OTP. Yes, that's why it didn't recognize it. OTP, yes, with our endpoint and OTP metric HTTP. Nice. Okay, and let's copy that here as well. With this kind of writing, I will not put anything. So with our metric 2, yes, we need a meter provider. First thing we will set is actually our periodic reader. So with periodic reader, we can export our meters every minute. The default is the every minute, but we can actually change that. So metric to dot reader with reader to new reader with our exporter. Yes. And next thing is defining a resource. So we already have that, something like that. We will create something like this trace. So it will be metric to dot with resource. Yep. Resource dot need with attributes. I will just copy here. I hope it will work. No, it didn't. No. I don't know what I did. Yes, like this. We need to set our meter provider. These step completions are really great. Not every time, but I think it's great. So we will return our meter provider and nil. Yes. So that is how we can create our meter provider. And so we can call this function within our main Go file, like we did it in here, like it here. So how it is, we can just get here and we can just copy it and say restart init meter provider. Yep. And say meter provider shutdown. Right now we have our meter in our application, so we can right now generate metrics and export them. So first metrics that we will use are for RPMs and response times. We can get those data with FiberPrometheus. FiberPrometheus actually a Prometheus middleware for Fiber. We are using Fiber in our application. So with that data, with this library, we can get total requests, duration seconds, and request in progress total. So we will use it. So let's install it. FiberPrometheus. We already have our Fiber. Golang. I will go get FiberPrometheus. So now after we have Fiber, we can use this middleware. So let's say FiberPrometheus.new. Yes, service name. It is other API. That is FiberPrometheus. Great. And that FiberPrometheus, let's say Prometheus. They are conflicting. Prometheus dot, yes, register our application. Let's register our metrics for metrics endpoint. It is a standard to export our metrics to metrics endpoint for applications. So let's use that middleware. That use our Prometheus dot middleware. Right now we are actually registering our middleware Prometheus to our application. So let's start our application again and rerun it. Let's go mode ID and run again. So let's first call some of our applications within here. Get order by ID. We need a GUID correlation ID, so say GUID generator. And for our ID, we have an ID. Nice. Let's call a little bit. Not one. Okay. So we need to have our metrics endpoint. Metrics. Yes, metrics endpoint. Yeah, as you can see, we have our metrics right now. We have a duration seconds bucket for order 1, status code 2000, etc. We have HTTP request total and HTTP request in progress. Great. So we have our first metrics. With these metrics, we can create our RPM and response times. So let's jump to our Grafana, that was in 3000, right? Let's get our Docker Compose. Grafana 3000, yes, and that's why, yes, it is 3000. If you are opening it the first time, when you are logging in, it is admin. No need password. Thank you. Okay, we can get to here and dashboards. I already have one before, but I will create a new dashboard. Yep. And say let's add visualization. So we need to actually connect our Prometheus in here. So in order to Prometheus, you will not see Prometheus first in there, so we need to say configure a new data source. And when you are here, let's see our Prometheus, and so you will write Prometheus, and our Prometheus is at 1990, and you can just save it, and that's how you can actually connect your Prometheus. It is a simple thing to do, and we can get to our dashboard again. So we have one data source, and that is Prometheus. And then now we can create our first visualization, and that can be RPM, right? So our query will be, it is actually a PromQL. So if you want to learn about what is PromQL, it is a Prometheus query language. You can check out their documentary, but most of them are the same thing. So it can be a little bit confusing at the first time, but in time you are just getting used to it. So our RPM will be, actually we had an HTTP request total that's coming from FiberPrometheus. We are getting the rate for per minute, and then we are actually summing by job. So when we run our query, as you can see, we have a 2 RPM in here. Okay, as you can see, we have a time series and we have our RPM. So let's call a little bit more so we can increase it. So if I didn't sum my job, by the way, and I run query, as you can see, I have all that I have all that 234, all that requests, but I want the total of them. That's why actually I am summing them by job, because they all have the order API attribute, so that's why I'm grouping them. Okay, as you can see right now our RPM has been increased, so we can just say RPM for this, and let's apply. Okay, let's save this dashboard as well. Order dashboard, order API dashboard, save it. Now let's create a second one, and that is for response times. So in order to get the response times, we had a metric for duration seconds. Yes, duration seconds. We can use this, and that is how we can use it. So we are actually getting the rate for our second, for our histogram by minute, and let's run it as well. As you can see, RPM, it's not RPM, sorry, response times is quite great because I'm calling it in my local, but maybe in future we can deploy our application to somewhere, to another network, and that's how we can see some latency in there. But if you want to see a real latency, you can just put some sleep in your threads, so you can see the latency in there. I will just say response times, something like that. Apply and save it. I don't want to see the legends, so I will just say visibility to false. Oh, we have a legend in here as well. Yeah, I don't have a reason. I just wanted to do that. Okay, now we can create some custom metrics. We can create a dashboard to see shipped orders for the last week, how many orders we have shipped in the last week, how many orders that have been cancelled in the last week, something like that. Okay, let's jump to the code then. Code. Okay, so we will have some. So in order to create some custom metrics, we can create a folder, a file for it. In here, trace is, I think, suitable. Let's say custom metrics. Yes, let's first create some variables. We will have 2 metrics, so first one can be, and that is a metric, but so we will have a gauge, observable gauge. It can be int 64. Why it is observable? Because if you remember, we have created a meter with a periodic reader in here, periodic reader. So it will actually observe every minute. So we will create a function that's getting the data from the database and export that data to Prometheus. And that function will run every minute with our periodic reader. So the second one is cancelled order metrics. Yes. So our first function will be initializing our custom metrics. So init custom metrics, something like that. What do we need? We need a database. So a naming starting is actually important, because if you are using OpenTelemetry Metrics in your company and if you have a lot of projects, you need to actually be careful about namings in order to avoid conflicts. You can use your team name, your domain name, and a detailed information about that specific metrics, something like that. Or will be order metrics, something like that. And we can create an option and say, yeah, I create a description, and those descriptions are accessible with that data, so we can use them in our Grafana as well. Number of ship metrics, yeah, something like that. So let's create that and say shipped. No, we already have that. Shipped. Updated, so we need to see one shipped order 1 minute later, right? So I will wait a little bit, like 1 minute.
1 eternity later.
I think it has passed 1 minute, so I will just get to our dashboard, and dashboard in here, not dashboard, it adds a visualization. So in here we can write down our metric name, which was shipped order metrics, right? So we can just say shipped order metrics and run query. Oops, no data, and we don't have a time series. We can just use a stat, but we don't have the data, so we need to see the problem. What is wrong? What is wrong? Why don't I see it? Okay, now we have one, because I didn't actually register my metric as a parameter. That's why actually I didn't actually export that data to my metric. Okay, now we have actually shipped orders, and that is 1. And that is how actually we can create our customer metrics. So maybe let's get this and get our cancel orders as well, and we can actually make it and a method and say shipped, and actually we will get the same thing for canceled order metrics. So it will be something like that, but or cancelled order metrics. Let's name it cancelled, so it doesn't create a conflict. Cancelled. Okay. In here we will say is cancelled is true in the last week, and we will get that data and register it to cancelled order metrics. That's how I'm good at copying data. Cancel order metric. Okay, I think that's all. Is cancelled. Okay, do we have a cancelled order? I think we don't have one, so this is cancelled true, so I will say the 28. this, and I will update it as well so we can see the 2 number. Yes. Okay. Now let's run it again. It will create data within a minute, and in that moment we can create our dashboard. So this was for shipped orders, right? Save it and let's get that to here. Okay, RPM, response times, shipped orders. Now we will have cancelled orders, and that was cancelled order metrics, I think, right? Yes. And run metrics, no data still, so it didn't have 1 minute. So let's wait a little bit. 1 million years later. Okay, we have logs, recorded metric, shipped, cancelled, 2 cancelled orders. Nice. Run queries. Run. Yes. Great. We have our cancelled orders as well. Then that's how you can export your custom metrics via Prometheus and see and create dashboards in Grafana. As you can see, you can create RPMs and response times and custom metrics, and actually if we would have an application in Kubernetes or a deployed application, we would have a resource usage as well, something like that. That would be good. And that's all for today. That is how you can create your metrics in OpenTelemetry with OpenTelemetry. Like I said, I will share the details. Like I said, I will share the code base in my GitHub. It will be in the description. That's all for today. Thanks for watching. See you in the next video. May the force be with you.